Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at the penultimate question, question 24, on our 2017 Gauss paper. Four vertices of a quadrilateral are located at 7, 6, negative 5, 1, negative 2, negative 3, and 10, 2. The area of this quadrilateral is... Okay, so we're looking for area. Let's just sort of draw a grid. The XY axes. And plot the points. So, what have we got? 7, 6. Maybe we'll put 7 about here and 6 up. Not quite as high. First number is how far over to the right. Second number is how far up. Negative 5, 1. So that might be somewhere back here. Negative 2, negative 3. And finally 10, 2. So a little further out. Well, now the way I've drawn it, and of course it's not that accurate, although if you want to be more accurate, one thing I recommend you do is see if your proctor will allow you to bring in graph paper. Not all proctors will allow brought in paper, but they should mostly allow paper. This looks an awful lot like a rectangle. Okay, but of course that might just be how I've drawn it. If I suspected that, well, what could I do to check that out? Well, if this were a rectangle, then to get from negative 5, 1 to negative 2, negative 3 would be the same as how do I get from 7, 6 to 10, 2. And so what do? We go down by 4 and over by 3. And sure enough, we go down by 4. Negative 4 added on to 1 is negative 3. And over by 3, and we'll look at that. We also have a 3, 4, 5 triangle, so the side length of our rectangle, well, we don't actually know it's a rectangle yet, but the side length here is 5 for both of these. And you can do that by either knowing Pythagorean triples or saying it's a right angle triangle, side lengths of 3 and 4 are going to give me a 5 there as well. Alright, so if I continue to suspect it's a rectangle, which is what it really looks like once I draw it, we would ask, okay, how do you get from negative 5 to 7? Well, you go over by 12 and up by 5. And interestingly enough, 5, 12, and 13 is another Pythagorean triple. So that's kind of nice. But do we get the same thing down here? Well, if you go over by 12 from negative 2, you do get 10. And if you go up by 5 from negative 3, you do get 2. So this is really just a 5 by 13. Well, now, it isn't actually a rectangle, is it? Because we don't know that these are right angles, but we do sort of see that this is a parallelogram. Certainly looks like a rectangle, though, but I don't think it actually is. Okay, but we want the area, and yeah, it's not a rectangle, unfortunately. But we can still figure out how to get the area, because if I connect up these outer points that I've used to sort of show that it was a parallelogram, I've found a few things. Okay, I've found that we get a 3 and a 4 rectangle down here, a 5, 12, 13 rectangle up here, another 3, 4, 5 rectangle, or I'm saying rectangle, triangle, and another 5, 12, 13, and these are all right angle triangles. Now, we've got a big rectangle that is 9 by 15, so we know the area of the big black rectangle, and then we can take away the areas of these smaller triangles, because they're all right angle triangles, very easy to compute their area. So we're going to want 9 times 15 minus 2 triangles in the corner that are 3 by 4. So 1/2 base of 3 times height of 4. And then minus 2 triangles, the other 2 corners that are a base of 12 and a height of 5. So what are we going to have? Well, we'll have 9 times 15, so that'll be 135, minus the 2 and the halves will cancel out. Another way to see that is if I took this triangle up here and I sort of slid it along, it would fit into place here and make a 3 by 12 rectangle. Or not 3 by 12, 5 by 12. But we have a 3 by 4, so that's 12, and a 5 by 12, that's 60. So we need 135 minus 72. And that's going to end in a 3 and start with a 6. So we're looking for an area of 63. So 63, there it is. I'm actually curious as to why they didn't put 65 as a possibility, because I almost thought that this was a rectangle just based on how I'd drawn my picture. But 63, that was, what, B? There we go. Yeah, so B, and that finishes off question 24. We just have one more question to go. Question 25. I'll see you for that next time.